Welcome to Dice Classes. Hi children, today we can discuss about local maximum, local minimum, absolute maximum, absolute minimum, or it is sometimes called global maximum or global minimum. How can we explain the concept of local maximum? A function which is continuous in a closed interval, say a comma b. This is a function which is continuous in the closed interval a comma b, has maximum and minimum. That is the first theory. As maximum and minimum if it is continuous in the closed interval. Option can be there. It has maximum but no minimum. It has minimum but no maximum. Maximum or minimum. All these are wrong. The correct answer is if the function is continuous in a closed interval a comma b, it has both maximum and minimum. Now, what is meant by local maximum? Local maximum means the maximum or minimum which exists some nearby points, like a valley. In a valley, there exists a hill. So many such small hills will be there. Hills are having different heights. So height of one hill can be local maximum. Height of another hill can be another local maximum. So a function can have many number of local maximum, same way many number of local minimum. But absolute maximum or absolute minimum will be only one in a given interval. That is the main difference. So to get local maximum, local minimum, the function f of x, when you differentiate, f dash x should be either 0 or f dash x not defined. That means we are finding critical values. Critical values are obtained at those points where f dash x either equal to 0 or f dash x not defined. So let us consider f dash x equal to 0 or f dash x not defined cases. F dash x is 0 means the tangent, if you draw at that point, it will be parallel to x-axis. So it is very clear from this graph. Here is a point, say x is equal to c, tangent is parallel to x-axis. So f dash, the c value is 0. So at this point, it can be local maximum or minimum. From the graph, it shows minimum. And here d, there also tangent is possible. F dash d is 0. There is a maximum, that is called a local maximum. And here is a tangent which gives f dash e equal to 0. So these two are valley and this is the hill. So nearby two valleys, there is a hill. So we will call it as local maximum, local minimum. This point is local minimum. This height is the local minimum height. X equal to c is called local minima. This point, x equal to d, gives local maximum. This height is called local maximum. This is local minimum. So you can see there are two local minimum values. There is one local maximum. Absolute maximum or absolute minimum can be at these points or some other points where f dash x need not be 0. Since the interval is from a to b, you can see at a the function is gaining maximum value, but there if you draw the tangent is not parallel to x-axis. So you cannot say f dash a, is it a 0? No, f dash a is not 0. But still, we can call this height as absolute maximum. This is called absolute maximum. Absolute maximum. And here, this point is local minimum. Even you can call it as absolute minimum because that is the smallest height possible for this graph under the given interval. So a local maximum can be absolute maximum or local minimum can be absolute minimum depending on different functions. Now consider another graph. See this graph. Here is x equal to a, f dash x is 0 or f dash a value is 0. From the graph it is clear it is giving the maximum value. We draw, this is a little shorter, okay. Yes. So this is maximum. You can call it as local maximum. This is minimum. Tangent is drawn at x is equal to b. F dash b is 0. So you can call it as a local minimum. Nearby local maximum, that is a local minimum. And this is the place where it is not defined. What is not defined? Derivative is not defined because we learned wherever sharp edges or corners are there for a function, the function is not differentiable. But still, that point, say x is equal to c, is called critical point. At this critical point, we are getting a maximum only. That maximum is called local maximum. So here, this height is called local maximum. This height is also called local maximum. This height is called local minimum. And this is the point where function is not differentiable because there is a sharp corner. But still, you can call this height as local minimum. Local minimum. So local maximum or minimum will get only at those points where the function is not differentiable or the derivative of the function at that point is 0. These are the two conditions. And here, this local maximum can even be called as absolute maximum. And this minimum, which is smaller than this one, no? That is called local minimum. At the same time, you can call it as absolute minimum also. So this is the way, by looking at the graph, we are identifying whether maximum or minimum is available or not. Now, using first derivative, how can we identify a function is maximum or minimum? Using first derivative, let us consider graph at x equal to c. Nearby c, left side of c, if you draw a tangent, the tangent is making acute angle. So its derivative dy by dx or f dash x will be positive. Just right side of c, if you take a tangent, the tangent is making acute angle. So acute angle making slope will make negative value. So dear children, you can see at c, left and right, the tangent value vary from positive to negative. So when f dash x varies from positive to negative, then that particular point x equal to c is going to become a maximum value. So this is a local maximum. What about local minimum? Say x equal to b. Immediately left side of b, if you draw the tangent is making acute angle or obtuse angle. This makes an obtuse angle. So the derivative is negative. Right side of b, here if you draw the tangent, it makes acute angle. Its slope will be positive. So you can see for local minimum, the slope varies from negative to positive. So local maximum using first derivative, f dash x varies from positive to negative. F dash x varies from positive to negative. That is what is called f dash x greater than 0 to the left side, f dash x less than 0 to the right side. For local minimum, f dash x varies f dash x varies from negative to positive. So instead of considering left to right, we can say c minus h. See, c is taken. Left side we can take c minus h. That is slightly smaller than c. Right side we can take c plus h. So when x varies from c minus h to c plus h, slope varies from positive to negative for maximum. For minimum, local minimum, c minus h, or here it is b, So b minus h to b plus h, when you move, slope varies from negative to positive. This way we can identify whether the function is maximum or minimum. Right? Now we can see second derivative test, how it is helpful. So this is first derivative test. Second derivative test, where we can take first order derivative, second order derivative. Second order test is, say at x is equal to a, first derivative should be 0 at x is equal to a. Then second derivative at a should be less than 0. So these are the conditions required. F dash a equal to 0 and f double dash a should be less than 0. For getting local minimum, say at b, f dash b, that is tangent should be parallel to x-axis. That is what is called f dash b equal to 0. Then its second derivative should be greater than 0. Second derivative should be positive. Then local minimum. Second derivative is negative. Then function is local maximum. Those x values which gives maximum and minimum are called maxima. So x equal to a is called maxima. X equal to b is called minima. So minima will give minimum, maxima will give maximum. Suppose the function second derivative is becoming 0 instead of getting positive or negative. If it becomes 0, what happens? So there is a point somewhere here, you can see at x equal to c. If I draw the tangent, see, I am drawing a tangent. So tangent is dividing this graph into 2. Here when I draw the tangent, it's very nice to see the entire graph lies one side of tangent, that is below. Curve lies below the tangent. Here you can see tangent and curve lies above. But here if I draw the tangent, one side of the tangent, other side of the tangent, both sides of the tangent curve lies. That means, so f double dash c at this point will be 0. Such points where second derivative is becoming 0 and third derivative is not equal to 0 is called point of inflection. So from the graph, how do you know there is a point of inflection? You just draw a tangent at that point and check whether the graph lies on either side of the line. If it lies that way, then that particular point is known as point of inflection. So this graph has a point of inflection. Similarly, our sine graph, when you draw the sine graph, see this point 0. At this point, if I draw the tangent, this is the tangent. T stands for tangent. One side, other side. So this point is called, where you are drawing tangent, that point is called point of inflection. Here, this is phi. Phi. If I draw the tangent, no doubt, one side, other side, curve lies. So all these are point of inflections. Point of inflection. So sine graph has infinite number of point of inflections. What about f of x equal to x cube? This is the graph of f of x equal to x cube. So at this x equal to 0, if you draw the tangent, x axis itself is the tangent. So there you can see one